Alright, so thanks for tuning in. We're going to continue practicing with properties of exponents. So feel free to follow along with this video as long as you need. With multiplying, the coefficients out in front we will treat just like normal multiplication. But then when we get to exponents with the common base, so a to the fifth and a to the negative ninth, multiplication of a common base implies addition of the exponents. So 5 plus a negative 9 is actually a to the negative fourth. But you'll notice the instructions say do not leave any negative exponents in your final answer. So anytime you have a negative exponent, it's really equivalent to moving it to the denominator. So I got 15 over a to the fourth. Alright, for number 2, first thing I'm going to do is kind of look at this as multiplication, so 7x times the quantity 3x cubed to the second. So order of operations, if I think back, before multiplication actually comes the exponentiation. So I'm going to take care of this chunk here first. So I get 7x times, and then 3x cubed all squared. That's essentially 2 copies. So 3 times 3 is 9. But then again, when you have multiplication with exponents with a common base, it implies an addition. So it's going to be x to the 6th power. So 7 times 9 would be 63, and this x here is really x to the first. So 1 plus 6 gives me x to the 7th is my final answer. Alright. So for question 3, again with negative exponents, I wish I was there to prove it with you, but what you should have seen from earlier notes is that anytime you have a negative exponent, it's going to move to the opposite side of the fraction. I'm just going to write this as x to the first, just so I know. I kind of use it as a placeholder. So x to the negative 7th is going to go up as x to the positive 7. So this is really x to the first times x to the positive 7. The 4 will stay down below. Alright, so using properties, multiplication with common base is addition. So I get x to the 8th. Notice that y to the 0, anything to the 0 power is 1. So my final answer is just going to be x to the 8th, all over 4. Let me just rewrite that. Alright, for question 4, we have negative 5x to the 8th times y, all raised to the 3rd. So again, that's 3 copies. So what I kind of think of this as is it's negative 5 to the 3rd times x to the 8th to the 3rd times y to the 3rd. All of that times, I'm going to rewrite this as negative 1y to the 6th. So it's a little bit different this time when you have a power to a power. So negative 5 to the 3rd, that's negative 5 times negative 5 times negative 5, so 3 copies. You can double check with the calculator, but you should get negative 125. Unlike before, now that we have a power to a power, that's multiplication of the exponents. So it's going to be x to the 8 times 3, which is 24, times, and then I have y to the 3rd times y to the 6th. So again, it's multiplication with a common base. Now it's addition. So 3 plus 6 is 9 times -1. And then I always multiply the constants just as we normally would. So our final answer will be 125, x to the 24th, y to the 9th. Alright, for question 5, I kind of take this one piece at a time. So if I said to reduce 5 over 15, that's going all the way back to first semester, so reducing that fraction. They both have a factor of 5, so right away I'm going to get 1 over 3, and I'm going to leave a lot of space because I'm not sure if I'm going to have more variables up top or down below. Alright, so when you have division with a common base, it implies subtraction of the exponents. I have more x's up top. And so 7 take away 2 would mean I have 5 copies of x. And then I really have y to the first. Let me use a different color. Y to the first. So 1 minus 1 is 0. Or in other words, they'll divide each other out. So my final answer here, you could write 1 in front, but it's essentially just x to the 5th over 3. If you don't see that, it's okay. You can always expand it out. So what I see some students do is they'll rewrite. But if it's x to the 7th, they'll write 1, 2, 3. So they'll write it out 7 times. 1, 2, 3, 4, 5. And then down below we have 2. So x over x is 1, x over x is 1, and then I'm left with the 5 copies, which is in our answer. So just a visual way to see that if you're struggling. Alright, so again with negative exponents, things do get a little tricky, but x to the -4th is going to move down as x to the +4th. So we have 2 over 3 x to the 7th, all raised to the -2. So the negative sign, that's going to reciprocate everything. So I get 3x to the 7th over 2, all raised to the 2nd. And then again, anytime you square something, it's 2 copies of itself being multiplied. So it's really 3x to the 7th over 2 times 3x to the 7th over 2. So multiplying numerator with numerator, I get 9x. And again, your brain's kind of doing 2 things. It multiplies the coefficients out in front, but then with the exponent, it's a common base, so you must add. So 7 plus 7 is 14. And then, of course, 2 times 2 is 4. So I get 9x to the 14th all over 4. Alright, so number 7 and 8 look pretty similar to each other, but they're actually a little bit different. If it helps, you can read this as 3 times x to the 0. So in question 7, only x is being raised to the 0 power. We know anything to the 0 power is 1. So for question 7, I got 3. But for number 8, because the entire quantity is being raised to the 0, you can look at that as 3 to the 0 times x to the 0, which is 1 times 1, which is really 1. So they're very similar in appearance, but you get different answers for both of them. Alright, we're almost done with the notes here. For questions 7 and 8, Do know that there's a lot of correct answers. There's not one correct answer that will work. So here's what I mean by that. If n to the something times n to the something is n to the 6, we essentially need both of these boxes to be two numbers that add to 6. So one example could be 3 and 3. I would also accept like n to the 5th times n to the 1st. So just to reiterate, when we multiply variables with a common base, in this case they're both n, then we add the exponents. I've even seen some students get creative and do like n to the -2 times n to the 8th, and that still works too. So a lot of correct answers for that one there. Alright, so it's always a little trickier with the negative exponents, but one thing that you could do is if I make, let's say, 1 over p to the 10th, the final answer is really p to the 10th or p to the 10th over 1. So if I can just reciprocate this entire fraction, that would help me get to the final answer. So if I just raise that all to the -1. So just to reiterate, when we have a negative exponent, we switch to either the numerator, so I'll put num, or denominator. Maybe I should abbreviate that. And again, there's multiple different answers here, so I've also seen students do like 1 over p to the -10 to the first power, because p to the -10 would just go up as p to the 10th. Alright, for the level up, I'm not going to give you my complete solution here because I genuinely want you to try if you're ready for that additional challenge. But I will give you the final answer is -2xy to the 10th, so I worked this out ahead of time. So I encourage you to try that on your own if you're feeling up for the challenge, and if not, you can start homework 2.